It's just a friendly reminder that like our video. And don't forget to subscribe for next free videos at ThunderEDUC.
Increase in the temperature of the reaction. So we are saying that you have two graphs, graph A and graph B. This graph shows that at a higher temperature, the graph looks like this. At a higher temperature, the graph looks like this. And then at a low temperature, you'll find out the graph looks like this. So what is the major difference between this and this? Why is at a higher temperature it looks like this? So this shaded part shows the particles which have enough energy or more than the activation energy so that they can react. So if you look at the number of particles here, if you draw a line here at a low temperature, you find out that only these particles from here to here have enough kinetic energy to react to form into products or more than activation energy. But if you look at this, the number is bigger compared to this. So it shows that here there are few particles which have enough kinetic energy to convert into products. But here it has more particles which can be converted into products. So when you increase the temperature, you are increasing the kinetic energy. You are increasing the speed at which these particles are moving. Increase in the temperature, you are increasing the speed at which these particles are moving. And then this causes more collision. So if the temperature is too high, then it means that there's the activation energy is going to be lowered, or many particles will have more kinetic energy, and then they can be converted into products. That's why you see here that here the reaction or the graph is covering more particles if you draw a line here, and then here it is covering fewer particles. So it means that if you have more kinetic energy, it means that the particles which are going to react are going to be more, and then more products are going to be formed. So increase in temperature increases the rate of chemical reaction. So at higher temperature, the graph is wider and most probably energy is higher. So if you look at it, the graph is wider. It means that it has more particles which can react, which have enough energy. And then the number of additional particles with energy or is greater than the activation energy, therefore enough energy to react or to react with the other reactants. And then this one shows that the most probable energy at low temperature. So at low temperature, this is the most probable energy, and then most probable energy at high temperature. You see that the energy here is, look at this, you see that the particles have a lower energy, kinetic energy. And then if it is a higher temperature, you find out that the energy increases from this point to this point. If this is 0, 2, 4, 8, 10, you find out that this one will have like 8 and this one will have like 12. And then it means that it has more. If it is at higher temperature, it has more kinetic energy. So that's how we can explain this graph. At a higher temperature, the average kinetic energy is higher than at a low temperature. So at a higher temperature, the kinetic energy is higher than, if you look at this is a low temperature, this is at a higher temperature. You see that the speed at which these particles are moving is lower than the speed at which these ones are moving. So when there is a high temperature, there will be more kinetic energy, and this more kinetic energy will make the collision to happen. So if you look at these ones, you see that anytime they can collide, but these ones, they are slow. The speed at which they are moving is too low. Then it means that the rate at which they collide is going to be low. So we are saying that more particles have kinetic energy greater than the activation energy. So if there is a high temperature, you find out that there will be more particles having more kinetic energy greater than the activation energy. And the moment the energy or kinetic energy is greater than the activation energy, then the reactants are going to be converted into products. More effective collision will take place per second. Then it means that reactants can be converted into products. Another factor is the effect of increasing in the concentration of the reactant.